The problem I'm doing for my video is going to be y equals x to the fourth minus 3x to the third plus 3x squared minus x. First thing we're going to do is find the domain. To do that, well, since it's a polynomial, the domain is going to be negative infinity to infinity. But to factor this, you could factor it to x times x minus 1 cubed. Now we need to find intercepts. So to find the y-intercept, we solve for f of 0. So that's plugging in 0 for all of the x's. Which equals 0. So there's a y-intercept at y equals 0. To do the x-intercept, you do the opposite. So we're going to set our equation, which will use the factored form, equal to 0. So we have x equals 0, and then x minus 1 equals 0. Add 1 to both sides to get x by itself, so we have x equals 1 and 0. So those are our x-intercepts. Next thing we're going to do is find if there's symmetry or not. So we solve for f of negative x to see if we get the same equation. So all you're doing is plugging in negative x for all the x's. Which is so that gives us x to the fourth plus 3x to the third, minus 3x squared plus x, which is not the same equation, so there's no symmetry. Next thing we're going to do is find if there's any asymptotes, but this is a polynomial, so there are no asymptotes. So the next thing we can do is find where f is positive and where f is negative. So to do that, we're going to take our intercepts, our x-intercepts, put them on a number line. So we have 0 and 1. Then we put our factors over on the side, so we have x, and then we have x minus 1 cubed. So x before 0 is going to be negative, x in between 0 and 1 is going to be positive, after 1 is going to be positive. This is going to be anything less than 0 is going to be a negative minus 1, so that's going to be negative, cubed is negative. Anything less than 1 is still going to be negative, cubed is negative, and then after this will be positive. So our f is positive, and then negative, and then positive. So f is positive from negative infinity to 0, and from 1 to infinity. Then f is negative from 0 to 1. So that's how you find where f is positive and where f is negative. Next, what we're going to do is find the critical number. So to do that, we solve for f prime. So f prime here is going to equal 4x cubed minus 9x squared plus 6x minus 1. This factors to x minus 1 times 4x squared minus 5x plus 1. That factors also to x minus 1 squared times 4x minus 1. So we can set that equal to 0, so when we find f prime equals 0, and where f prime does not exist, well, this is a polynomial, so it does exist everywhere. So we set x minus 1 equals 0, and 4x minus 1 equals 0. Get x by itself. X equals 1. Get x by itself. Divided by 40, x by itself. X equals 1/4. So those are our critical values. Now, what we can do is put those on the number line. Put our factors over here, x minus 1 squared, 4x minus 1. And then we have our 1/4 and our 1. anything squared is going to be positive. Anything less than 1/4 is going to give you less than 1, so it's going to be negative. Anything bigger is going to be positive. So that means that f prime is negative, positive, and positive, which means f is decreasing, increasing, and increasing. So f is increasing from negative, f is increasing from 1/4 to infinity, and then f is decreasing from negative infinity to 1/4. So we know that every time that f prime switches from negative to positive, there's a local min, so that means there's a local min at x equals 1/4. If you plug that back into the original equation, you come up with the point 1/4 negative 27 over 256. So there's a local min there. Next thing we can do is find concavity. So to do that, we take the second derivative of the function. So f double prime equals 12x squared minus 18x plus 6. That factors to 6 times 2x minus 1 and x minus 1. So now we find where f prime of x, or f double prime of x equals 0, and where f double prime of x does not exist. Well, it's a polynomial again, so it exists. So we set 2x minus 1 equals 0, and x minus 1 equals 0. X equals 1. Add 1 to both sides. Get x by itself. Divide by 2 to get x by itself. So x equals 1/2. And x equals 1. So now we put those numbers on the number line. Put our factors over here. So we have 6, 2x minus 1, and x minus 1. So then we also have 1/2 and then 1. So 6 is always going to be positive no matter what, because it's a positive number. Anything less than 1/2 is going to give you a negative here, positive here, positive here. This is going to give you a negative here, and a positive here. So f double prime is positive, negative, and then positive, which means that f prime, or just f, is concave up, concave down, concave up. So f concave up from negative infinity to 1/2, and then also from 1 to infinity. F is concave down from 1/2 to 1. So then we know that there's a point of inflection wherever concavity changes. So we have one at 1/2 and 1. So if we plug those points in there, we can come up with, if we plug 1/2 into the equation, we get 1/2 and negative 1/16, and then we also get, if we plug in 1, we get 1, 0. So those are points of inflection. Now we can take all of this and put it on one chart, so we can start to graph it. So we take all the numbers that we used on the number line. So we have 0, 1/4, 1/2, and 1. Then we have f, just f, f prime, f double prime. So we had f was positive, negative, 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 and then positive. We had decreasing, decreasing, and then increasing to infinity. And then we had concave up, concave up, concave up, concave down, concave up. So from negative infinity to 0, 0 to 1/4, 1/4 to 1/2, 1/2 to 1, and then 1 to infinity. So if it's decreasing and concave up, it's going to look like this. If it's decreasing concave up, it's going to look like that again. Increasing concave up is going to look like this. Increasing concave down is going to look like this. And then increasing concave up is going to look like this again. So we can finally graph this. We have 0, 1, 2, 1, 2. So we know that we have an intercept at x equals 0 and x equals 1. We know that we have a point of inflection at 0, 1, or 1, 0. We also know we have a local min at 1/4, negative 27 over 256. And then we also know that we have a point of inflection at 1/2 and negative 1/16. So we can plot those. So we know from negative infinity to 0, we're concave up and increasing. We know that from 0 to 1/4, we're concave up and decreasing and we're negative. Then we know from 1/4 to 1/2, we're concave up and increasing. And then that's an inflection point, so concavity switches, we know we're concave down and increasing until we get to 1. And then from there on out, we're concave up and increasing all the way to infinity.